Hi, Dr. Revis here. In this video, I will give a lecture on stoichiometry, including mole-to-mole conversion factors. There are three objectives. One is to help to define what stoichiometry is. The second objective is to discover why stoichiometry is important. And then a third objective is how to use stoichiometry in chemical equations. When we consider stoichiometry, it's really about the relationships between items that are required to produce a particular function or device or item. For example, if you have one bike requires one frame plus two wheels. If you have a clock, 2 hands plus 12 digits gives you the one clock. Or if you play poker, 2 kings plus 3 aces equals a full house. The relationship between the items and what it takes to form the items is what we call stoichiometry. So, whether it's a bike, a clock, or a full house in poker, or even the tiles on a gym shower floor, the relationship between the items and the finished product is an example of stoichiometry. So how do we define stoichiometry when it comes to chemistry and to reactions? Stoichiometry in chemistry is defined as the relationship between the relative molar quantities of substances taking place in a reaction or forming a compound in whole integer ratios. Now, what does that really mean? What it means is we look at the relative quantities in moles of the reactants and the products to determine its stoichiometric ratio for a particular reaction. And those ratios are reported as whole number integers. So let's take an example. Let's say you want to grill hot dogs. Propane plus air is what produces the flame. Propane plus air are the reactants. The flame is the product. Propane is C3H8. The component we use from air is oxygen. Together they form combustion. If we look at the reactants and the products, we find this chemical equation. This is the chemical equation for the complete combustion of propane. However, this equation must be balanced by determining the number of each of the species on the left and right side of the equation. For more on balancing equation, see my other videos. Once the equation is balanced, we examine the coefficients in front of each species or each compound in the reaction, both on the reactant side and the product side. These coefficients represent the molar ratios. This is our stoichiometry. Each reaction has its own unique stoichiometry. For example, the complete combustion of propane has a different molar ratio of reactants and products than the incomplete combustion of propane. By the way, complete combustion gives carbon dioxide, incomplete combustion gives carbon monoxide. In chemistry, we don't write ones in our final analysis of the stoichiometry. Therefore, a clean version is shown here on this slide. So we have 1 mole of propane plus 5 moles of oxygen gives 3 moles of carbon dioxide and 4 moles of water. So what do we learn from this balanced equation? We discover that 1 mole of propane requires 5 moles of oxygen to undergo combustion. When it undergoes combustion, it produces 3 moles of carbon dioxide and 4 moles of water. These are two examples of molar ratios that may be used in calculations involving stoichiometry. But there are others. For example, there is a relationship of 1 mole of propane to 3 moles of carbon dioxide. There's also a relationship of 5 moles of oxygen to 4 moles of water. But then any of these relationships may be inverted. In other words, stoichiometry is about examining the ratios of reactants to products, reactants to reactants, or any other species in the balance equation. Another relationship that is useful in stoichiometry is the relationship of grams to moles. Note that stoichiometry involving grams to moles can be carried out. However, stoichiometry cannot relate grams to grams. So, let's use an example. Dr. Revis is having a cookout. What quantity, mass, grams, of carbon dioxide would be released into the atmosphere for every 490 grams of propane, C3H8, consumed? Here we show you the balanced equation for propane. We would carry out this operation by first writing our given 490 grams of propane and the desired outcome, grams of carbon dioxide. We would then carry out a dimensional analysis, as shown here. 490 grams is converted to moles. The moles of propane are then converted to moles of carbon dioxide, and the moles of carbon dioxide are then converted to grams of carbon dioxide. We then add the values as shown here. Important to note is the conversion factor of 3 moles of carbon dioxide per every 1 mole of propane. When we carry out the calculation, we obtain 1,467 grams as our calculated value. However, since our given has 2 sig figs, we report that as 1,500 grams of CO2 produced. In carrying out this process, what we find is that we are essentially converting 490 grams of propane to 11 moles of propane, and then converting the 11 moles of propane to 33 moles of carbon dioxide to give the final mass of carbon dioxide of 1,500 grams. Here we show you the roadmap. 490 grams converted to 11 moles of propane was interconverted to 33 moles of carbon dioxide, which was converted to grams of carbon dioxide. The interconversion of the 11 moles to 33 moles of carbon dioxide illustrates the strength of stoichiometric ratios, where the mole-to-mole ratio of propane to CO2 was used based upon the coefficients in the balance equation. Let's do another example. Dr. Revis drives a truck. What quantity, mass, grams of carbon monoxide could be released into the atmosphere for every 302 grams of octane consumed if his carburetor, oxygen, and his catalytic converter are not operating? Here we show you the balanced equation for producing carbon monoxide, which is produced when there is incomplete combustion of fossil fuel. The roadmap involves taking the given grams to convert to the moles, which is interconverted to the target moles, which is then used to calculate the grams of the target. So let's start with our given of 702 grams. We're interested in how many grams of carbon monoxide is produced. So we carry out a dimensional analysis. The first step, we start with converting the 702 grams, which is converted to moles of octane, which is interconverted to moles of carbon monoxide, which is then converted to grams of carbon monoxide. Our given has 3 sig figs, and our final answer must likewise have 3 sig figs. For a lecture on how to calculate significant figures, sig figs, see my other videos. So, what is stoichiometry? It's an examination of the coefficients that define the balanced equation. Why is it important? It defines the molar ratios of reactants and products. And how do we use it? We use it to carry out inner conversions of chemical quantities within a balanced equation. There you have it, a lecture on stoichiometry including mole-to-mole conversion factors.